As laboratory instructors, we teach many different laboratory procedures to students, who then perform these procedures as part of their lab activity. We've all had the experience of completing a demonstration of the procedure we're about to do, then letting the students loose to perform the procedure themselves, only to have them ask questions about the exact same thing we've just said a few minutes earlier. Why is a live demonstration not always effective at teaching procedures? Let's take one example, the four-quadrant streak. When you break it down, there are several aspects of this procedure that students have to pay attention to. They have to see the pattern of the streak, which we usually draw on the board or show them in their lab manuals. They probably won't see the streak pattern very well on the plate we're holding during the demo because the streak marks tend to disappear into the agar, or because they're too far away. But because we emphasize the pattern in this technique, that's probably what they're trying to pay attention to. So often they miss information about the flaming and cooling the loop, such as the timing of this part of the procedure. They usually remember they're supposed to flame and cool the loop in between each quadrant, but they miss the timing. You'll often see students at the bench waiting 5 minutes for the loop to cool down, or waving it in the air, or even blowing on it. They don't have a sense for how long to leave the loop in the flame to sterilize it, or how long to allow it to cool so that they don't kill the bacteria when they go back to the plate to continue their streak. Then they have to wait until the next lab period to find out how successful they were. The bacteria need time to grow, so even if they have lab in a couple of days, their feedback on the procedure is separated from their actual performance of the procedure by a length of time. And they aren't necessarily going to remember the details of what they did to connect those details with their results. And then the plate isn't saved forever, so they lose the ability to look back at how their streak turned out. If we break these components of the lesson down into separate learning goals and make pedagogical choices about how best to teach each piece, then we can see if there are other tools we can use to enhance our instruction beyond the live demo. Harris and Hofer, for example, in their 2009 paper, Grounded Tech Integration, recommend this approach to assessing whether technology tools may be usefully employed to increase the effectiveness of instruction. After deciding on the learning goals, we can decide on a pedagogical strategy, incorporating each of these 8 parameters along a continuum. Once we have a strategy for each component goal, we can design activities to teach that goal and design assessments. Then we can think about the modes of communication and tools we have available to us and how each might be best suited to conveying specific pieces of information. Gunter Kress, in his video discussion of modes, notes that different modes make meaning in somewhat different ways, each mode adding something slightly different to the same topic. People then choose modes to create meaning in accordance with the aptness of the mode to the meaning conveyed. Thus, video, audio, image, text, and live interaction each has different affordances that may be used to convey to the student information about the procedure we're trying to teach. Our traditional live demo has certain affordances. It combines voice and gesture with the affordances they provide, but it lacks others. By revising our lesson to include the modes most appropriate to the piece of information we're trying to teach, we should be able to create a more effective lesson. We've identified 5 component learning goals for our lesson on the 4-quadrant streak, but let's take just a few examples to show how this revision process might work. Our third goal, for example, is for students to use appropriate timings for flaming and cooling the loop. Students often misunderstand this part of the procedure, how long to leave the loop in the flame and how long to let it cool. We can identify some of the parameters of this part of the lesson using Harris and Hofer's continuum. We may recognize that students have little experience with this technique, and we may want to lengthen the amount of time they have to absorb this piece of the lesson. Furthermore, we recognize that this is time-related information, so it makes sense to show this part of the procedure using a mode that conveys the passage of real time. We want an activity that will show that. We could use live action in our traditional demo activity to show students how long each of these steps takes. But the advantage of video is that it not only affords students the ability to watch the procedure unfold through real time, but also the opportunity to review the procedure prior to coming to lab, and to view it as many times as is necessary until they get a feel for the rhythm of the action. In a real laboratory, no one sits and times these steps, so with experience, laboratorians develop a sense for how long these steps take. Our fourth goal is for students to remember what they did so that they can connect it with their results later. This part of the lesson is very student-centered, so we may want this to be more individualized, so that the student acquires a deeper knowledge of the connection between the details of the procedure and the results they obtain. With our traditional lesson, we haven't provided a means for students to record their observations of how the procedure goes for them. Written notes could be used, but students often balk at providing much detail in written lab notes, so they may seem somewhat cryptic when read several days later. A voice memo would be much faster, easier, and provide more immediacy. There are some safety challenges in bringing personal electronic devices into microbiology labs due to contamination concerns, but the phone is probably the easiest device to incorporate into lab work. It can be put back into a pocket when not in use, cleaned with an alcohol prep pad if necessary, and it doesn't need to sit out on the bench where the hazards of contamination are greater. Also, it's a technology most students are already competent with. Students could record their observations of how they performed the procedure immediately after completing it for later review. A voice recording affords the students the ability to hear their description expressed in their own words, with inflections and expressions that are most meaningful to themselves. Finally, we want students to be able to review and assess their own results as part of our assessment strategy. This is how students will improve their technique later as laboratory professionals. So in addition to teacher-centered assessments, we want students to learn to assess their own work. So we want activities that are student-centered and individualized. We also want the learning to be convergent, so that all students learn to perform this technique in a similarly consistent way. Since plates cannot be removed from the lab for safety reasons, we want an activity that will record the students' results. A photo record of their results will allow them to compare what they see with the results their peers have obtained and with their own voice notes on how the procedure went for them, as well as with the feedback they get from their instructor. In some ways, this is the most crucial aspect of this instruction, as it allows for students to assess their own performance of the procedure and make changes in how they perform it, so as to obtain better results the next time. The use of technology tools allows students to post a picture of their plate on a Padlet, along with pictures from their peers, so that they can see how close they are to achieving a standard result. Students could also create a voice thread with their picture, allowing both their instructor and themselves to comment on the results and suggest any changes that could be made to improve them. These digital tools facilitate a higher level of detail in the feedback and allow the student time to absorb and review the feedback as well as reflect on their own observations. Working through this process for all our component learning goals keeps those goals and pedagogical strategies as the driver of our instructional design, as we identify activities and assessment strategies that will help students achieve the performance goals. Our strategies are informed by the choices we make about which modes best communicate what we are trying to convey, which ones are most apt for our purposes. Only after making those decisions do we look at digital tools to see which ones will allow us to implement our strategies most effectively and help our students achieve the performance of a professionally competent 4-quadrant streak.